Children, it is time for another quiz warm-up. So before you watch this video, you need to attempt the quiz warm-up yourself. And after you have tried the quiz warm-up yourself, then watch this video. So pause the video, pause it, pause the video. Now that the video is paused, you should be working on your warm-up. And if you heard me say that sentence, that means you finished your warm-up and then you pressed play. I don't know how many times I have to say it, but if you're watching these videos without trying the warm-up by yourself, you're really hurting yourself in the long run for when you take your quiz. Because if you can't do the warm-up by yourself, then you won't be able to do the quiz. That's why we made the warm-up. So just something to think about. I hope you tried it by yourself. Let's talk about scientific and standard notations. So remember that all scientific notation has to be in the format of some front number that's called a coefficient times 10, and the 10 will always be raised to some power, some exponent. You actually know automatically that if you're writing scientific notation, you need that format. So you could even, before you do anything else, put those times 10s in there to remind yourself that's what you're doing before you even look at the real problem, because then you're less likely to forget to do this part at the end. Like a lot of the time I'll have people only put the coefficient and then they just sort of forget about the times 10 to some power part. And then I have to take points off because they didn't finish their answer. So I would just stick that times 10 in there from the beginning. So it's one less thing to worry about, kind of a reminder for your future self. From there, when you're looking at the standard notation side, you need to decide if the exponent of 10 is going to be positive or if it's going to be negative. And that depends on how this number compares to 1. If it is a number greater than 1, then you're going to have a positive exponent of 10. And if it's a number less than 1, then you're going to have a negative exponent of 10. Again, those are decisions I make before I do anything else, because I want to make sure I don't forget to do those tiny, easy steps. So I would actually start there. You write your times 10, and then you decide if your exponent's going to be positive or negative, because once you do that part, early, you don't have to worry about forgetting to do it later. From there, remember that your coefficient is going to be a number that is between 1 and 10. So, you could write it like this. Whatever your coefficient is has to be greater than or equal to 1, and it has to be less than 10. Something to think about. That's like a fancy math way of writing between 1 and 10. And that means you're going to have to take the decimal point and move it and count how many times you move it. Now, on this top problem, they didn't write the decimal point, but you understand that the decimal point is right next to the ones place, right? There's your ones place, the decimal point's right next to it. So you know where it is, and then you're just going to keep moving that decimal point. When your number is bigger than 1, you want to make it smaller to get it closer to between 1 and 10. And you can kind of see that happening. Like once I move it to right here, I've now made 43,405, which is much smaller than it used to be, and closer to 10 than it used to be. So I'm going in the right direction, but of course that's not small enough. So I keep going. You get it over here and you're looking at 434. That's not between 1 and 10, so you move it again. 43.4, that's not between 1 and 10, so you move it again. 4.34, oh yeah, that's a number between 1 and 10. So I'm going to stick that coefficient into my answer box. I know that's going to be times 10 to some power, a positive power, because my starting number was greater than 1. And now to know what that power is, I just count how many times did I move it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to just stick a 9 as my exponent there. And to do the second problem, similarly, I need to move the decimal point This time, I need 0.000004119 to get closer to 1 and 10. So I'm going to need to make this number bigger. So if I move the decimal this way, then again, you can start seeing I'm making it bigger and bigger. Instead of 0.0000004, I'm now making it 0.04. If I move it again, I make it 0.4. If I move it again, 4.119. That is between 1 and 10. So that's where I'm going to stop. I know that that coefficient is going to be times 10 raised to some negative power. Again, we know it's negative because the starting number was less than 1. And to figure out exactly what that power is, I just count how many times I moved the decimal, and this time I moved it 8 times. When you go backwards, you're given scientific notation, you have to write standard notation. Again, the first thing you got to do is check if that exponent is positive or if it's negative. A positive exponent means that whatever number you're writing as your answer needs to be greater than 1. And a negative exponent means that whatever number you're writing as your answer needs to be less than 1. So if I think about that, that means that for this 6.72 times 10 to the third, the 3 tells me I'm moving it 3 times. The fact that the 3 is positive tells me which way to move it. I need to make this number be bigger than 1. If I move it this way, that's going to make it smaller than 1. That would make it 0.6. That's smaller than 1. That's the wrong way to move it. So instead, I'm going to make it 67.2, 672. When I move it the third time, there's nothing there. So I put a placeholder 0 in that spot, and I end up with 6,720. When I do the bottom problem, again, the 6 tells me to move the decimal 6 times. The negative tells me I need to make this number smaller than 1. So if I were to move the decimal the same direction as the previous problem and I move it this way, 5.7 becomes 57. That's making it much bigger than 1. That's the wrong way to move the decimal. So I need to reverse directions this time and move it 6 times the other way. 1, 2, 3, 4, 5, 6. Did I count that right? Yeah. So the decimal ends up over here. And again, I fill all those empty spots with placeholder 0s. So my final answer is going to be 5 zeros point, and then 5 zeros, and then 576, which is a number less than 1, which is good because that negative exponent over here told me I needed a number less than 1. Okay. For these calculations, if you have a graphing calculator, you can do this in your graphing calculator. If you have a Chromebook, there's that link that, as far as I know, at the time of this recording at least, still works on Chromebooks only for a graphing calculator, like Chromebook app. If you have neither of those things, then the other way to do these problems is going to be using Google Sheets is probably the easiest way. You could use your phone calculator, or like Google itself as a calculator, but that is usually, when scientific notation is involved, not the most simple way to calculate these problems. So if you don't have a Chromebook and if you don't have a graphing calculator, then I would suggest just using Google Sheets. And I'll move my window to share my Google Sheets with you in a second. Before doing that, I do want to remind you the way we type this in a calculator when it's scientific notation is we'll type the coefficient, so just type 5.45, but then instead of like hitting the times button and instead of typing 10 and instead of hitting that little caret button, we're not going to do any of that. We're going to instead use an E for exponent, engineering exponent, and that E says basically it knows the times and the 10 part, and it's saying now you can just type the exponent. Whatever the number of the exponent is, just type it like normal. So just a 19 right there. And the way you get the E, in case you forgot, on a TI 84 Plus and most TIs, you hit the second button and then you hit the comma button, which for most TIs is right above the 7. Again, if depending on what model calculator you have, that might not be exactly where it is, but on most TIs, there's a comma button right above the 7, and you hit second and then that comma, that's what's going to get you the E. Okay. Let me change my screen share here. There we go. Okay, you can see I'm just using the same Google Sheet every time I'm use a calculator in any of these videos. Some of these are from older videos, so I'm just going to scroll down to an empty spot. And I'm going to start typing some problems in here. So the first one says 5.45 times 10 to the 19th. So again, you can just type in E19 in there. And then that's going to be times 9.78 times 10 to the negative 2. And then to calculate them, I'll hit this equal button, and I'll tell it do what's in that box. It's called a cell. Times what's in this box. You can see, again, what these A44, B44 mean. They're color-coded, and it's saying, like, here's column A, row 44. Here's column B, row 44. So take the number that's in here times the number that's in there. And then you press enter, and it gives you it back. 5.33. E plus 18, that means times 10 to the 18th power. So what you're going to write down on your paper is 5.33, and then you have to write it when you're handwriting it as times 10 to the positive 18. When you type it, you can use the E. When you're writing it, you need to write out the scientific notation. The next problem, 6.27 times 10 to the 4th, so that's E4. You'll notice that Google Sheets actually changes the exponent to this format every time. It always makes it 2 digits, and even if I didn't type a plus, it always writes a plus for me. That's just a nice little convenient thing that it does. The next one is a fraction, 5.26e negative 20 over 7. And I usually just type my fractions as like one box over the other for numerator over denominator. That's, like, to me, the easiest way to do it. Then when you type this out, you again have to hit the equal sign, and then it's going to be that cell, and then it's going to be times, and then it's going to be this fraction. Remember, a fraction is a division problem. So if you really want to get technical, you need a parenthesis right here to make it calculate the fraction first. But if you understand algebra enough, you'll know that though doing it that way is actually not going to change. Like for this particular problem, not including the parentheses is not going to change your answer. You'll get the same answer, but that's because you're not dividing by scientific notation or dividing by something with a 1 on top. It's a whole thing. Just if you're using the E, you don't have to worry about parentheses. That's the point I'm trying to make. If you were not using the E and you were typing it like 6.27 times 10 to the 4th power times 5.26 times 10 to the negative, like if you were typing it all out like that and you ended up dividing by scientific notation, then it would be a problem if you did not use parentheses. But if you're using the E, you don't have to worry about parentheses. That's my point. Anyway, it's a order of operations thing. Okay. On your paper, for that second problem, you're going to write 4.71 times 10 to the negative 16th. When you write it out, you got to write the times 10. When you type it, you can use the E. It's a shortcut. Next problem. Typing it in, and I know it's going to be this times this divided by that. Technically, if you think about it, this first one is like a fraction. It's 3.33 e negative 16 over 1. But having that in your calculation won't change anything, right? Like multiplying by 1 divided by 1 is not going to change anything. So you don't really need to write it out unless it just makes you more comfortable. You definitely don't need to type it out because multiplying by 1 or divided by 1 is not going to change your answer. And then the final one, 4.10 e negative 12. Negative 12. And this is similarly, I know that multiplying times this 1 is not going to change anything. So if I'm paying attention, I could just divide by that numerator right there. If you wanted to do this times 1 and then divide it by that denominator, it's going to give you the same answer. So notice the directions on this page don't specifically mention it, but I think they were supposed to mention that all your answers need to be in scientific notation. I'm positive that on your quiz, all your answers need to be scientific notation. So if you did this on a graphing calculator, it would actually probably tell you 0.592. It won't automatically put it in scientific notation for you. So that's something you have to be paying attention to, because all your answers for this quiz need to be in scientific notation. So keep that in mind. Even if your calculator doesn't give it to you in scientific notation, you need to give it to me in scientific notation. So don't give me this. Give me the scientific notation. Okay. So double check you wrote all your answers down correctly. I'm pretty sure I wrote all my answers down correctly. Hopefully when you did this by yourself, if you did anything wrong, you now know what that was. And yeah, good luck on your quiz. I believe in you.